Point defects in non-stoichiometric crystals. The compounds in which the ratio of positive and negative ions present in the compound differs from the required by ideal chemical formula of the compound are called non-stoichiometric compound. The defects in these compounds are called non-stoichiometric defects. For example, iron oxide, right? Iron second oxide. Iron second oxide. Iron second oxide of ideal composition, FeO, are difficult to obtain. Normally, we get samples of more oxygen, right? Normally, we get samples of more oxygen atoms than iron atoms. It may range from 0.93 iron oxide to Fe 0.96 oxide. Non-stoichiometric defects. If as a result of imperfection, the ratio of number of cations to anion becomes different from that indicated by the ideal chemical formula, the defects are called non-stoichiometric defects. These defects arise either due to excess of metal atoms or non-metal atoms, or presence of impurities or foreign particles. Metal excess defect. The solids with metal excess defects contain metal ions in excess to the stoichiometric ratio. Such defect is caused due to anionic vacancies and excess of extra cations at the interstitial site. First, due to anionic vacancies. Now, in this case, negative ions may be missing from their lattice sites. Okay, negative ions may be missing from their lattice site, leaving holes. Now, in this case, a hole is created in which electrons remain entrapped. What happens now? In which electrons remain entrapped to maintain the electrical neutrality. इसमें क्या हुआ कि नेगेटिव एनाइन जो है वो बाहर गया, उसकी जगह पर इलेक्ट्रॉन जो है उसने उसका स्पेस ले लिया. तो यहाँ पर what happens here? The anionic site occupied by an unpaired electron is called F center. This center. The anionic site occupied by an unpaired electron is called F center. F stands for, here, F stands for far Ben Center. Center. We are having T-E-R. Far Ben Center. Which is a German word for color center. Far. So in anionic vacancies, in anionic solids, anion may be missing from its lattice site, leaving a hole which is occupied by electron to maintain electrical neutrality. The anionic site occupied by an unpaired electron is called F center. F stands for far Ben center, which is German word for color center. F center are responsible for the color of the compound. This kind of defect is shown by alkali halides such as NaCl, KCl, etc. Now, metal excess defect due to presence of extra cations at interstitial site. Now, we discuss about the metal excess defect, right? Metal excess defect. Second type now. Now, this is the crystal, right? In this type of defect, metal excess is caused by extra cation, right? इसके अंदर जो भी metal excess होगा वो extra cation करेगा. Is caused by extra cation occupied the interstitial site, right? ये crystal है. Now what happens? This is an extra cation. Extra cation क्या हुआ? एक इंटरस्टिशियल साइट पे आ गया. To maintain electrical neutrality, because it is an ionic compound, to maintain electrical neutrality, what happens now? Extra electron is also present in some other interstitial site, right? What happens here in this type of metal excess defect? What happens? क्या हुआ यहाँ पर? Extra cation occupied the interstitial site, and to maintain electrical neutrality, extra electron is also present in some other interstitial site. Beta, this defect is found in crystals having Frankel defect. So from here, in this crystal, what happens here? In this type of defect, metal excess is caused by extra cation occupied by the interstitial site. To maintain electrical neutrality, extra electron is also present in some other interstitial site. This type of defect is found in crystal having Frankel defect. Example, zinc oxide. Yes, example, zinc oxide. Right, this is the example. Now, whenever we are talking about zinc oxide, it is white, colorless solid at room temperature. Okay. When we heat it, जिंक ऑक्साइड को आपने क्या किया, हीट किया. What happens now? When we heat zinc oxide, it loses oxygen and turn yellow color. हमने जिंक ऑक्साइड लिया, व्हाइट कलर है, ठीक है, एट रूम टेम्परेचर. हमने क्या किया, हमने उसको हीट किया. जैसे ही आपने उसको हीट किया, इट लूजेस ऑक्सीजन एंड टर्न येलो कलर. मीन्स ZNO heating, it converts to Zn2 positive, oxygen. This is the reaction which take place. ये reaction हुई. अब इस reaction से what happens? Why there is a yellow color? Because in this case, excess Zn2 positive ions trapped in interstitial site and released electron which get trapped in neighboring interstitial site and maintain electrical neutrality. Right? So crystal with either of these metal excess defects contain some free electrons, hence such materials are semiconductors. Now the second type, metal deficiency defect. In certain cases, one of the positive ions is missing from its lattice site and the extra negative charge is balanced by some nearby metal ion acquiring two charges instead of one. Right? इसमें क्या है कि अब हम मेटल डेफिशिएंसी डिफेक्ट कहते हैं. मींस यहाँ पर नंबर ऑफ केटाइंस जो है बेटा वो कम होंगे एज कंपेयर टू द एनाइन, लेकिन इलेक्ट्रिकल न्यूट्रलिटी मेंटेन रहेगी. To maintain neutrality, same metal ion having high positive charge is added. Right? For example, we are having FeS. Iron pyrite. Right. Now, what happens here? Suppose we are having a crystal. Right. It is made up of Fe2 positive S2 negative. Fe2 positive. Suppose Fe2 positive. This one is S2 negative. This is F2 positive. S2 negative. Right? S2 negative. Fe2 positive. In this way, the crystal is formed. Right? Now, what happens in this crystal? This type of defect is created by metal ion goes missing from their side. Suppose in this case, Fe2 positive, this Fe2 positive, and one more Fe2 positive. Okay, missing from their side. Now, what happens here? To maintain neutrality, same metal ion having high positive charge is added. Means here now Fe3 positive is added. Here also Fe3 positive. But this remain as such. The vacancy is created. Right? Vacancy is created in the crystal. As a result, the crystal has a metallic luster. ऐसे क्या होगा? As a result, crystal has a metallic luster because of the natural color of iron pyrite and metallic luster. It is named as fool's gold. It is named as fool's gold. So there is evidently a deficiency of metal ions, although the crystal has a hole is neutral. This type of defect is generally found amongst the compound of transition metals which can exhibit variable valences. Like in this case also, in example also, Fe is having 2 positive and 3 positive. Crystals of FeO, FeS and NiO show this type of defects. Thank you.